Hi everyone, so welcome to my channel. So uh, I'm thinking of starting a playlist where I will be solving one question every day or every alternate day, and I'll be sharing the solution. I'll be coding along and recording my thought process and everything that I think and I do when I'm solving the solution. So let's see how this goes, and you can follow me around for during this entire process. So let's see how everything goes. So so today I came across Bellman-Ford, this algorithm. So I didn't came across this, but today in my college today they taught us Bellman-Ford. So I learned a lot. I learned about that and implemented Bellman-Ford, and now I'm going to solve this solution negative weight cycle that I came across in GFG. So let's see how to solve the solution, and how I think of coming up with a kind of solution that I think is optimal, or let's see if it passes the test case or not. So okay, so the question is given a weighted directed graph with n nodes and m edges. Okay, and node and m edges. Nodes are labeled from 0 to n minus 1. The task is to check if it contains a negative weight cycle or not. Okay, edges I is defined as u, v and weight. Okay, n equals to 3, edges equal, okay, so the edges are given in a two-dimensional array, and I think the first one is u, and the second value is v. U is I think the source and v is the destination, I guess, and then the third value is the weight from going like from when you go from u to v. Then the cost is given in the third as the third value. Okay, so n equals to 3 and edges is this much. Okay, so we just have to input whether it yes or no. Okay, so 0 and 1 we have to just print out 0 or 1. The graph does not contain any negative weight cycle. Okay, so if there is no no negative weight cycle, so we have to return 0, and if it contains, then we have to return 1, I guess. Okay, you don't need to read or print. Okay, so let's see how. I think so, like I know that in a Bellman-Ford algorithm, what we do is like we relax every edge n minus 1 times. Okay, and like this is the property if there is no negative weight cycle in the graph. So according to the Bellman-Ford algorithm, there will be no more relaxation after n minus 1 relaxations, at most n minus 1 relaxation. So what I'm going to do is remove this. Okay, so first how so we are given this n that represents the number of vertices. Okay, so like if we loop through for int I equals to 0, so like if we like if we run the Bellman-Ford instead of n minus 1 to n like n times or if we run it n minus 1 times and then again run it for one time, and if any of the edges relax in that extra traversal or extra relaxation step, then we conclude that there exists a negative weight cycle. So what I'm going to do is like for like Bellman-Ford n minus 1 iterations, there should for n minus 1 iterations I should relax and like calculate the shortest distance. So so I should have a distance array that will store all the distance. Okay, so n minus 1 times I'm going to relax. So what I can do is like I am getting a list of a 2D array of edges. Okay, so what I can do is like for int like edge equals to 0 to edge is less than how many edges are there. So edges dot length, this many edges are there, and edge will go one by one. Okay, now what is the source? Source is the edges of index edge, and the 0th index is the source. Okay, in the same way we can calculate the distance also. So the first index is destination, and similarly in the third index we have the weight of the weight of going from source to destination. So like this will be in the second index. Okay, here we have to initialize the distance with I'm going to use the arrays.fill property that comes with Java util package. I'm going to pass distance, and I'll set it to infinity. Okay, what is infinity? So let me define it here. This will be nothing but integer dot max value, that will be infinity. Okay, I'm going to set the the source. Okay, so like is 0 always the source? So that is not clear by this statement, but let's see. If 0 is the source, then I'm gonna set the distance from 0 to 0 is 0 only. Okay, now I'm going to relax every edge. How I'm gonna relax? So like the distance to source must not be infinity, and okay, so like source should not be infinity. So that is the source must have been visited. So it will run as we have already told that the the first vertex, or the first one we are starting. So I assume that edges of the 0th index of the first. Okay, so like this one is always 0. I'm assuming it. Okay, so this condition always gives 0. I'm assuming that. You can directly write 0, or you can just denote here that you can write in this. This will be more fault tolerant, I guess. Okay, so I would leave it like this only. Okay, now the distance of source not equals to infinity. Okay, and the distance to destination. Okay, so if the distance to destination is greater than from the source to the weight, source plus the weight. Okay, that means the cost of moving from so the distance of reaching destination. Okay, if that is greater than the distance from source to weight, then what we're gonna do is relax this step, relax this distance. So what we're gonna do is distance of destination, we are going to write it source plus the weight. Okay, so what I'm gonna do, so what I'm thinking or what I'm doing is so let's see, we are going so this is the source and this is the destination. Okay, let's say for reaching the destination the cost that is required is, let's say, 2x. Okay, 2x or something like that, and the destination, and then the cost of reaching s is, let's say, x. Okay, let's say it is x, and the distance from s to d is, let's say, 5. Okay, so I'm calculating that if x plus 5, okay, I'm calculating if x plus 5 is less than 2x. Okay, so what I'm gonna do is I'm gonna remove 2x and I'm gonna put x plus 5. So like this. Okay, so after relaxing all the like after running it for n minus 1 times. Okay, so n minus 1 is the number of vertices, like one less than the number of vertices times. If no more relaxation happens for like the nth time, then we say that there is no negative cycle. So how we're gonna do is, like, we're gonna copy this and paste it here, and instead of writing like this, like if it happens, let us just return 1. Okay, and if nothing happens, then we are just going to return 0, that there is no negative weight cycle. Okay, so instead of this, we can just like we can just remove it here. We can run it for n times, and here only we can write that if I is equals to n. Okay, so like if we are running for the one extra time, if you are running for the one extra time, then what we're gonna do is like return 1. Okay, that means there exists a negative weight cycle. Okay, I is less than n, so I can never be equal to n. Okay, so it should be, I think, equals to n. So let's see if it works. Compile and run. Come on, ready for evaluation. Okay, it shows 1. So okay, so here we are getting the right answer, but let us submit it and see if the answer is still right. Array index out of bound, index 0 out of, oh, okay, so this kind of cases must be handled, right? Okay, in the interviews we must handle this kind of so it is saying if there are no edges, then what you are going to return. So let's say if edges dot length is less than equals to 0. Okay, if even if it is 1, then also like there is no negative weight cycle, isn't it? Like if there are no edges, then there is no negative weight cycle. But let's say if there is only one edge, so if it is one edge, then how is there gonna be a cycle? Okay, whatever cycle, like negative weight or positive weight, doesn't matter. Okay, so we can do that. Let us test it. I hope there is no more exceptions. Okay, so it passed. Execution time 0.49. Okay, so that was it for this video. I'm gonna record another video, I guess tomorrow or day after tomorrow. So like, stay up with me. Okay, good night everyone.